guys. So today we're just going to look at this simple project that I'm working on, where you can do full-text search in MySQL. Okay, so like in MySQL you need to create like rows for you to fetch the data. Like you need to write where close, like and stuff. Yeah, but those things sometimes cannot retain the data that you want. Yeah, because the rows might not work because you're using keyword search instead of context-based search. Okay, so this is what vector database allow you to do because of vector embeddings and stuff. They allow you to query data with context. Yeah, not using keywords, which is the default behavior of MySQL databases. So for example, here as you can see, I can search for pixel, Google Pixels. If I want, I can say I can just change the query. Users sometimes don't write, like they might write something that is very different to what you have written in your backend for your search, so it might return 0 results. But this type of search is very powerful. As you can see, I just said I want Google Pixel. Okay, it gives me Google Pixel. If I change to I want a MacBook, I can still get the results. Okay, if I want, I can even remove. I just write a MacBook. Okay, I still get the results. Okay, and as you can see, it's even retaining the scores. Yeah, which is just like the distance between the query and what is stored in the database. So the nearest distance or the shortest or the smallest score is what is very near to the search query, which is the MacBook here. Yeah, so as you can see here, it would be this one, the MacBook Pro. So this guys gives you advantage when you're implementing your, for example, your search in your databases, in your products. Yeah, because this gives you the opportunity to do full text search, which is very complex, not the limited default behavior of MySQL. Yeah, it's very powerful, guys, and the good part, it is very free and open source. All the things that we have used here, they are very free and open source. Flask framework, SQLite, and ChromaDB. You only need those things. The database, you can pick the database of your choice. Yeah, so guys, I'll just take you through the architecture, the simple architecture. So as you can see, this is MySQL open source AI powered full text search. Yeah, so at the top layer we're just using Flask. Yeah, so Flask allows you like to create API endpoints. Yeah, then using Flask we have got these two endpoints, add product. Yeah, so what add product is using Chroma where we are running a client for Chroma vector database. Yeah, so this is how ChromaDB works. Yeah, so there is an embedding model that you use to create vector embeddings. So as you can see, you get the product's data, everything like the name, the product description, and all the metadata for the product. You create it into vector embeddings. Yeah, then you store them in the vector database, and when you store that information, that's when we now record that product into the SQLite database. Or I just use SQLite to make things simple, but you can use an SQL database or any database of your choice. Then you just return the product that has been stored in the database to the client, which is the user. Then the same process for searching for product. You go through ChromaDB. Okay, then you have to convert your search query into, again, vector embeddings. Then once you create, you convert your search into a vector embedding. That's when now you query your vector database. Then once we retain the results, then we use those results to now search to get the products. Yeah, ordering them using the score. Yeah, so yeah, that's the main the approach that we use here. Yeah, so you get your search query, convert it into vector embeddings, and you use those parameters now to search your vector database. Then so the algorithm that is used to search into the vector database is called cosine similarity, which just tries to compute the distance between what you are searching and what is stored in the database, in the vector database. The nearest ones, yeah, so it will get all the results that it finds together with their scores. So to know the what you are searching for, the ones with the what can I say, like the shortest distance, which is more like the score, is what is very close to what you are searching for. Yeah, so you search, so it will bring back maybe two documents. Yeah, it will plot two documents. Then based on the score or the distance, the one that is shortest or the one that is smallest is the one that is very close to what you are searching for. Yeah, so just now to take you through the code. Okay, so as you can see here, yeah, so we're just using Flask SQLite 3, ChromaDB, and the embedding functions to use the embedding models provided by ChromaDB. So everything is open source, nothing for paying, and your data still stays on your machine, nothing that you're sending to the cloud. Yeah. So as you can see here, we're just initializing the database just with the ID, the name, the description, and the price. Yeah, if the database is not created, we'll create it, which is what we have here. Okay, and these are like the products in the database. Yeah. Go back to the main. Yeah, then we because we want to persist like we have to create a vector embeddings database like on our machine, which gets created here, as you can see. So this is what ChromaDB will be using when you're trying to, the data gets persisted on your machine. Yeah, so guys, here we just use that. This is the embedding function that we are going to use. Okay, the default embedding function to create vector embeddings. Then we can store them in the database. Then we can later search them using cosine similarity algorithm. Yeah, but everything you don't have to do like search. You don't have to implement the algorithm yourself. Everything comes done by ChromaDB. Yeah, but you can also change the search that you want, the search algorithm that you want to use. Yeah. Okay, then we just create the collection. So as you can see, this is the collection name, products, and we just specify the default embedding function. If we don't put this, by default ChromaDB uses the default embedding function. You can even use OpenAI embeddings to use in under this collection. Yeah, then we just have the endpoint to add the product. So as you can see, first here we just save the product in SQL, okay, which is SQLite. Then we also add the product to the collection where we pass the product name. So they are added as documents, and you can also add the metadata for the product. So we are just adding for the document, we add the name and the description, and these are added like strings. Yeah, as strings. Okay. So then we have got here we just store the product ID. Yeah, so this is how we add the product. Okay. Then we just return to the user that the product has been added and the product ID. Yeah, so now to search, this is how we create the query. So the query comes from the user. Okay. Yeah, so request.ags.get query, we just get the query parameter that we pass through the HTTP request. Okay, then we get the query, which needs to be a string. Okay, I'll specify the number of results, so you can use any number of results there. So those are the results that what's this is going to use, ChromaDB is going to use. Okay, yeah. So from the results now, okay. So remember that we are storing the product IDs also in the database. So we can extract the product IDs, then we use those product IDs now to to now search, like for example here, to now search in the SQL database. Yeah, then once we get the results, then we just return the products. Yeah, so that's the basics of the API. So it's just the same thing that I was explaining here. Yeah, so you add the product, you store the embeddings, you return the results to the user, you will search, you convert the search query into embeddings, then now you search through the vector database, you get the IDs for the products, then now you find those products in the SQLi database, and now you return the products back to the client. Okay, yeah, so which is what's happening here. So now here, okay, yeah, so this is what I'm doing here. Yeah, so for example, if I can just add this, as you can see, we return the product ID and the message. Product has been added with product ID 11. Now if I come to my database here, we have 10 records, but if I just refresh, you can see we now have 11 with a product ID of 11, which is just like the same product because I added it already. Yeah, so as you can see, then now we also have, like, this is the search endpoint where we pass the query, I want a Samsung, which is here. Then once you pass, okay, then it returns the product and the score. So this is more like the distance, of the query and the results. Okay, so the shortest distance, so as you can see, this is 1.2, 1.3, 1.39. so these are ordered based on the distance that is returned from ChromaDB. Okay, so the shortest distance is this one. Okay, with this, which has the smallest score, which is of 1.2. So because it has got the shortest distance, it's the result that is very close to what we are looking for. Okay, so if I just change this now to maybe Google Pixel, okay, if I just search, okay, you see, so we have 0.7, 1.3, 1.38. So as you can see, as we go down, okay, the distance keeps increasing, or the score keeps on becoming higher. So this is how you can implement full-text search, guys, in your projects using SQL, ChromaDB and Flask, or any framework of your choice. It will be Fast API, okay, and Python, and you can implement this full-text search in your project. So if I want, I can say I am looking for Google Pixel. Okay, still I get I get the products, the results. Okay, I can search the results to I am looking, oh sorry, yeah, you see, I even made a mistake on the spelling there, but it was able to get to face the results, because it's not like using the exact match to make the query, but it is using the vector embeddings, which enables which enables AI like to create like some context, yeah, instead of doing like fixed search. Okay, I'm looking for something in the range of, okay, maybe let's say 1,500. Looking for something in the range of 1,500. Okay, you see, so the shortest, the price that we get is 1,800. Then it keeps going high, down like that, and even the score is something like this. Yeah, so guys, you can just check the video description to get the full source code for the collection that I'm using here, which is Full-Text Search, and also the code that has been used to create this. Yeah, so guys, if you like my video, share, leave a comment on what you would like to see next. Thanks very much. Yeah, for those who want to contact me, you can still use the video description. You find all my contact details.